Section 3.9a. This is example number 3 from the worksheet. If you don't already have the worksheet, please download it from Blackboard and follow along. A water tank has the shape of an inverted circular cone with a base radius 2 meters and a height of 4 meters. If the water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. So over here I drew a picture. This is an inverted cone, and I have put in arbitrarily h for height and radius for r. And then we're told the overall height is 4 meters and the radius is 2 meters. Okay, so step 1, find and label these 3 things: the given, the unknown, and the relation. Well, we're given that the change in volume with respect to time is 2 meters cubed per minute. It's being pumped into the tank at a rate of 2 meters cubed per minute. The unknown is find the rate at which the water level is rising when the water is 3 meters deep. So we're looking for the change in the height with respect to time when h is 3 meters deep. Water level and its height at 3 meters deep. The relation is the volume of a circular cone. That volume is given by 1/3 pi r squared times h. In this particular case, note that no derivative of r is given with respect to time or respect to its height. So we're not given that, nor do we need that. So in this particular case, there is the similarity between this triangle with the height and the radius and this whole triangle's height and its radius. So I can set up the similar triangle r over h. r over h is equal to 2 divided by 4. And when I solve that for r, I get r is equal to h over 2. Then what I did is in the volume equation, v equals 1/3 pi r squared is now h over 2 squared times h, which simplifies to pi over 12 times h cubed. So effectively, I've eliminated the fact that we were not given any information about the change in r with respect to time or the change in r with respect to its height. Because remember, as the height of the water is changing with respect to time, the radius would change. But we're not given any information about that. But that's okay, because of the substitution, I don't need it. So then I take the derivative, dv dt is equal to 3 pi over 12 times h squared times dh dt. Then I solve for dh dt and plug in what I know. So dh dt is equal to dv dt, which is 2, and then 12 divided by 3 is 4, pi, and then h, I substitute in for 3, squared. And that simplifies to my answer, 0.28 meters per minute.